What we're going to do next is run through some troubleshooting sessions. And what I'm going to do is I'm going to pause the video, purposely break something in our RIP topology here, and then we'll kind of look together. I'll act like I don't know what the problem is, and we'll kind of look through some different show commands to try to just make you think a little bit as we look through the outputs, and maybe you'll be able to, figure out the problem before I show you what I broke. So I'm going to pause the video. Alright, I'm back. I broke stuff while I paused the video, so instead of jumping into looking right at the configuration, there's different techniques on troubleshooting. I feel like most of the time in the real world, the configuration shouldn't have changed, and it's usually something else. Of course, that's the case in this scenario, but let's start with, I can tell you that something isn't right on R1. So we're going to jump in R2, and we're going to look at the output and see what we're missing here. Let's say that the PC connected off of R2 here used to be able to talk to the PC hanging off R1, but now it cannot. So I'll at least give you that to go off of. Okay, so let's maximize R2 here. Let's first look at our RIP routing table with show IP route RIP. And not just as I expected. Darn RIP. It takes a while for changes to clear out with RIP. So I'm just going to clear the routing table. You were supposed to see nothing there, so not what I wanted to see. Okay, so now we have no RIP routes. The user is complaining they can't talk to the R1 PC anymore. So first, let's do show IP protocols, and we can see that, okay, well, we see we're sending and receiving traffic out of our F00 interface hanging off R2. So we know that we're sending traffic and receiving it, or should be able to receive it. We see that we have our network statements there for our 172.16 interface facing R1, so that interface off of R2 will participate in RIP and send RIP messages. But for some reason, we don't have any RIP routes. Let's see if we can look at the same command output on R1 to see what the problem is. So we'll run show IP protocols, and let's see what's going on here. So we see that, okay, we have our network statements in here, so that right there proves, without even looking at the configuration, that we're advertising our 10.1 network, and we've enabled RIP for our 172.16.1 interface facing R2, so we know that's good. So moving down here, it's kind of interesting. We have all of our interfaces are passived out. We don't have any interfaces that are active. If you remember what R2's output looked like for that command, you can see that it actually had an interface here that was participating in RIP. But it looks like we do not have that same output here on R1. It looks like our F00 interface is passive. Is that what my sneaky trick was when I broke it? Let's look at the running configuration, and sure enough, we don't have any interfaces that were configured as no passive interface. So the passive interface default just defaulted everything. So to get this routing party started again here, let's go under our RIP configuration and let's double check which interface we need to enable to get this RIP advertisement going again. And we want the interface facing R2, so that's F00. So we'll say no passive interface, F00. Let's run the show IP protocol command again. And now it looks like that's what we want to see. Now we see we actually have that interface as an active RIP interface. So in theory, we should see a RIP route now on R2. We'll give it a minute here. There we go. So finally our rip route came in, and that was the only thing broken in the topology. All right, I'm going to break one more thing here. I'm going to pause the video, and I'll come back and we'll have one more troubleshooting session here. Maybe I'll break two things. We'll see. All right, we're back here. I broke some more stuff on our routers. This time, neither router is learning any routes. So let's start off with that. There might be another problem in there. Don't want to give too many clues. So let's hop into R1. And I think I'm going to stick with using the show IP route RIP and the show IP protocol commands for our troubleshooting before we look at the config. I feel like if you really start getting used to paying attention to the show IP protocols command, then it really can speed up troubleshooting for you instead of looking through a long configuration, even though RIP's configuration is not that long. Just stick with that. So let's see what we don't have here. So on R1 we don't have any RIP routes. Let's see if it's the same deal on R2 here. And that's the same case on R2. So while we're in R2 here, let's do show IP protocols. We still have our active interface on that side. It's not passived out. We have our network commands here. So just by looking at that, from what I can see, I would say that we are participating in the RIP protocol on that link between R1 and R2. Let's do the same command on R1. Okay, well, this is a little different. So we don't have an active interface, so it's kind of the same scenario as before, but our F00 interface isn't under the passive interfaces, so that tells me that it's not in the passive state. But if you look here, it says routing for networks 10.0000. So what's wrong with that? Let's see. So it looks like we don't have the 172.16 as a network statement, which would disable basically RIP on this connection. Let's see if that's actually the case here. And sure enough, we can see the difference between R2 and R1's configuration. We're missing the 172.16 network statement over on R1. So let's throw that bad boy in there. Give it a second. We know RIP takes a little bit to get going here. RIP will definitely teach you patience. I can promise you that. There we go. So that was it. Now that we enabled RIP on that 172.16 network between R1 and R2, we are back in business and advertising RIP routes. So now let's see if we have any other problems. So we're happy with R2's output. We can see that the only network from RIP it should really be learning is this 10.100 that it's R1 is advertising, so that looks good. Let's make sure now. Always got to verify everything after you have changes on the network. So let's run the same command over on R1 here. Wait a second. So we were expecting to get the 10.200 network advertised to us, but for some reason we have this 10/8. Well, that doesn't help us very much. So what is going on there? Let's well, it's R2. Let's think about this. So R2 is the one advertising the summary instead of the actual connected network. So let's look under our show IP protocols output and see if we can figure it out. So everything looks pretty normal. We have our F00 interface active in RIP. We have our network statements. Our F00 interface is not passive. But if you look here, we see that automatic network summarization is in effect. So let's look at our configuration. And this is how you can see how certain commands like the show IP protocols can be useful, because if you just look at the configuration, you eventually just know that auto summary is not in your configuration, but it might not jump out to you since you actually can't see it, because certain default parameters in router and switch configurations will not show up in the running configuration. So I think if we actually do show running all, it shows you every option, even the defaults, and then we'd probably see it. Holy moly. A lot of stuff going on in your routers that you don't realize until you do this command. Actually, you know what? I wonder if it'll let me do section with it. There we go. So there's actually a lot of stuff going on your RIP configuration that you just can't see because, again, certain default parameters just don't show up in the config. So that's actually a good command to show you certain things that, you know, I mean, we can see in the show IP protocols output, so it's kind of cleaner, but it's cool to actually see the configuration. So sure enough, we see auto summary is enabled because I removed it. Or I removed our no auto summary command to break things so that we got our summary advertisement. So that should fix it. It'll probably take a little bit with RIP, so I'll show you a little trick with working with RIP in the lab. Do not do this. I'll say it over and over again. Do not just do clear IP route star in a production network, but in the lab here it's okay. Unless you're willing to bind. And now that we cleared things out and we disabled automatic summarization again, we are receiving the expected route of the 10200/24. So now when we look at just the regular old running configuration on RIP here, we see that we have the no auto summary command in our configuration. One more thing we can take a look at for RIP troubleshooting, and that's debugs. So it's pretty simple. If you go under your RIP routers configuration and say debug IP RIP ? You have a few options. For this example, we'll just hit enter so it turns on all the debug options on both routers. And under normal operations, you'll see that we'll see the RIP updates that are sent out every 30 seconds. So we'll wait a little bit here to see those updates, and then I'll disable some interfaces on one of the routers or something, and we'll get to see something actually changing in the topology and see what we get for that. If you do unall, to actually undebug all, you can turn off your debugs after you get output if you want to look at it. So we'll take a quick look. We see that the R1 router was sending an update via the multicast address out its F00 interface, and then right when that was sent, of course, the other side received it, and then R2 sent an update and R1 received it. So nothing too crazy during normal operations. We're just going to see the periodic updates being sent out between the routers. So now I'm going to re-enable debug IP RIP, and let's see what happens if I disable an interface or something. So let me disable this interface and see what happens there. So there you go. So that was a triggered update that was sent out. So you can see a flash update, and we can see the route poisoning in this debug. So we sent out an update with a metric of 16, and you can see that it received the update, and it was in 16 hops, which made it inaccessible. So at that point, it would have removed it, from the routing table. So now we have no RIP routes. As soon as this goes back to that route poisoning feature with RIP that we talked about. As soon as a router wants to clear out the topology for a route, it's gonna, and it's still, let's see, what did it do here? So again, here we sent an update with a metric of 16 here with the infinite metric there. So that was kind of cool to see in the debug. Let's bring it back up and see what happens in the debug when the route comes back up. So another flash update. So flash update's also considered to be a triggered update. There was an event that triggered RIP to send out an update. So you can see that Now this time, when it sent its flash update, it sent it with the actual metric, which is 1, since it's 1 hop away. So now things should be normalized now, and we should have a RIP route for that route, and we do.